Learning Target 19 says I can compare the mean, variance, and standard deviation of two related data sets. So what I mean by two related data sets are, suppose you start with one data set and you add the same number to each number in the data set, or suppose that you take a data set and you multiply each number in the data set by the same number. How does that impact the mean, the variance, and the standard deviation? So let's do one example of each of those. So in problem number 1, it says your chemistry teacher gives a test that she grades out of 50 points. The statistics for the scores are as follows. She decides to give each student 2 extra credit points for being such great students. Find the new mean, variance, and standard deviation for the scores. So suppose you take a data set and you just add a number to each element in the data set. The mean is going to change. The mean is just going to increase by whatever number you added to the numbers in the data set. So your new mean is just going to be your old mean, which in this case was 40, plus whatever number you added to each number in the data set. So in this case, we're adding 2 extra credit points. So we're going to take the original mean, which was 40, add on 2, and that's going to give you your new mean. However, when you take each number in a data set and you just add a number to it, it's actually not going to change the variance and the standard deviation at all. And the reason why is that variance and standard deviation measure how spread out the data is. If you're just shifting each number up by the same amount, you're not making the data any more spread out or any less spread out. You're just sort of shifting it over, shifting it up by some number. So it's not changing how spread out the data is. Therefore, your variance and your standard deviation are going to stay the same. So our variance is going to stay 2.8, and your standard deviation will stay 1.673, and these do not change. So when you add a number to each member of a data set, it's going to change the mean. The mean is just going to go up by whatever you added to each number in the data set, and that will create your new mean. But your variance and standard deviation should not change at all. Now, there are different rules in a situation where you take each number in a data set and you multiply by something. So here's a different problem. So again, we're talking about your chemistry teacher that's giving a test that's being graded out of 50 points, and the statistics for the scores are given here. But in this problem, after grading the test, she decides she wants to put the scores into her grade book as out of 100 points. So she multiplies each score by 2. So suppose that you had gotten a 40 out of 50, that's going to count as being an 80 out of 100. Or if you had gotten a 50 out of 50, that'll be put into her grade book as 100 out of 100. So she's just taking each score and she's multiplying it by 2 so that it's out of a different number of points. And we want to find the mean, variance, and standard deviation for the new scores. So when you do this sort of a thing where you take an entire data set and you multiply each number by some number, in this case we're multiplying by 2, what's going to happen to the mean is just going to get multiplied by whatever you multiplied each number in the data set by. So we're going to take our original mean, which was 40, and multiply it by 2, and we end up getting out 80. The same thing is going to happen to the standard deviation. The standard deviation also gets multiplied by 2. The variance, however, does not get multiplied by 2. The variance gets multiplied by 2 squared. So we need to take our variance and multiply it by 4, and that will give us our new variance. So when we take each number in a data set and we multiply by some number, the mean and the standard deviation get multiplied by that number. The variance gets multiplied by that number squared.